Welcome everyone to this topic on decorators. We're going to discuss a more advanced Python concept, which is the decorator. And decorators allow you to, quote, decorate a function. Let's discuss what that word decorate actually means in this context. Imagine that you created a function. Here we're representing it by just a simple function. It does some simple stuff and then returns something. So you create this simple function and now you want to add some more functionality to it, or in other words, add more code. What you could do is take your original simple function, then add some more stuff to it, keep doing the old stuff, and then return something. But this idea of adding new functionality basically represents a problem, because you have two options here. Either you can add the extra code, otherwise known as adding functionality to your old function, but then you have a problem of not being able to call your original function. You've edited it in some way with that new functionality. The other option is to create a brand new function where you copied all the old code and then added new code to that. The problem with that, though, is now you had to recreate the entire function over again. Even though it's just a copy and paste, it's not ideal that you had to actually make another function. But what if you actually then wanted to remove that extra functionality at a later date? What we would have to do is delete that function or make sure you don't call it. So deleting it manually, making sure you don't have the old function, there's got to be a better way. So what would be nice is if you had an on-off switch where you could quickly add that new code or add that new functionality and then turn it back off again. This is where the decorator comes into play. Python has this concept called decorators that allow you to quickly tack on extra functionality to an already existing function. And then if you no longer want that functionality, you just delete one line from the decorator. So they use the @ operator and are then placed on top of the original function. So you can easily add on or turn off extra functionality with a decorator. So you just take your original simple function and then you have some decorator which connects to some extra code, and then you can add in extra functionality. Then if you don't want that extra functionality, you just delete that @some decorator line on top of the function. So this idea is pretty abstract when you actually practice it with Python syntax, because it's kind of this mysterious one-liner here on top of your function. So what we're going to do is we're going to go through the steps of manually building out a decorator ourselves to show what that @ operator is actually doing behind the scenes. And we're also going to learn about some concepts such as passing a function within another function. We're going to go step by step and build this out very slowly. So let's open up a Jupyter Notebook and get started. Okay, let's start off by actually building out our own decorators manually. We'll need to review a few concepts though, and introduce some new ones such as assigning functions or passing in functions into other functions. So what we can do is create a simple function called def_func, and this is going to return 1. So I can call that function and execute it, and I get back 1. Remember, we also discussed that if you just say func without open and close parentheses, you'll get back the information that, hey, you have a function here, you won't actually execute the function. That means we can actually assign functions to other variables and then execute them off that variable. So let me show you what I mean by that. For example, I will say create this hello function that returns back hello. So I can execute hello, or I can just ask, hey, hello, what is that? Well, it's assigned to a function. I could then say greet is equal to hello, and Python won't complain. In fact, now check out what I can do. I can say call greet, and it returns back the string hello. So what we want to ask ourselves is greet just pointing to hello, or has it made its own copy of the hello function? We can easily test that by deleting hello and then seeing if we can still call greet. So right now, I can still execute hello. I'm going to delete hello. And if I try executing hello now, it'll say, hey, hello is not defined. Makes sense, we just deleted it. Now let's see what happens when I call greet. So greet still returns hello. So even though we deleted the name hello, the name greet is actually still pointing to that original function object. And it's important to know that functions are objects that can be passed into other objects. So now let's show an example of passing in a function within another function, or calling functions within another function. And this is going to tie in a lot with that scope and nested statements lecture that we had previously. So I'm going to make a couple of new cells here just to clear that screen. And let's create a function called hello. And it takes in a name. We'll have the default name be Jose. And this simple hello function is going to say the hello function has been executed. So right now, if I call hello, it just says the hello function has been executed. Makes sense? Now let's define a function inside of this function. I'm going to now say greet, and what this does is it just, it's going to return, so notice I'm using return, no longer print, and it's going to print \t, that's a escape character for a tab, and it'll say this is the greet function inside hello. So if I rerun these cells, I still just get back hello function has been executed. So let's think about what's happening here. I have this function, hello. It takes in some default name by Jose, and it just prints out the hello function has been executed. We're actually not using the name yet. Inside of this function, I'm defining another function called greet. And greet returns, this is the greet function inside hello. Notice here, I'm just defining greet. I'm not actually calling it. So let's call it. Outside of greet, I'm going to print greet. Notice I'm printing it because greet returns back this string. So now when I run this, I get back hello, function has been executed, and then I get back tab, this is the greet function inside hello, because we defined it inside hello, and then we executed it inside hello as well. So let's define another function inside hello called welcome, and we'll do the same thing. We'll say return tab, this is inside, we'll say this is welcome inside hello. And then after greet, we're going to execute welcome. And it's really important here that you pay attention to the indentation because it's really easy to mess these up. I have the indentation here for hello, and everything else here is lined up. And then I have these two lines indented because they're part of the greet definition and they're part of the welcome definition. I don't actually call greet and welcome inside of these functions. Instead, I call it only inside hello. So notice here how these print statements are lined up with hello. You can always copy and paste from the notebooks in case you're getting any sort of indentation or syntax errors. So when I run this, I get back hello function has been executed, and we have these tabs here to kind of show that the greet and welcome function are actually inside the hello function. And at the very end of all this, I can still say this is the end of the hello function. So I run this, the hello function has been executed, I define greet, I define welcome, then I actually execute greet, execute welcome, and print this is the end of hello. Now something to notice here is that greet is defined inside of the hello function and welcome is defined inside of the hello function. That means their scope is limited to the hello function. I can only execute greet and welcome inside of hello. If I try to execute them outside of this hello function, for example, if I try to call welcome, it says, hey, welcome is not defined, which makes sense because it was only defined inside of this hello function. And as long as you didn't define greet earlier, it will also end up being an error. So here we have this idea that greet and welcome, their scope is limited to hello. But what if we want to access these functions outside of hello? What we could do is have the hello function actually return a function. Remember that up here, we were able to assign functionality in this manner. It'd be really cool if our hello function, instead of just printing out the execution of greet, it returned greet. So here's what I'm going to do. I'm going to delete these 3 lines, and then I'm going to print out, I am going to return a function. And we'll say if the name is equal to Jose, return greet. Else, return welcome. Okay, so let's think what's going to happen here. Right now, my default name is Jose. I print out hello function has been executed. Then I define 2 functions. One's called greet, one's called welcome. I print out, hey, I'm going to return a function. And then we say, hey, if the name was Jose, return the greet function. Else, return the welcome function. What that's going to allow us to do is it's going to allow us to return a function which we can then assign to a variable, just like we did earlier up here. So let's see an example of that. We're going to say my new func is equal to hello, and we'll pass in the name Jose, which is also the default name, so you could just say hello. And I get printed out, the hello function has been executed, I'm going to return a function. So because the name was hello, this function, after doing these two print statements, it actually returned back the greet function, which was defined inside of hello. And now, if I call my new func, notice here it says function main.hello.locals.greet. So it's actually now pointing to that greet function inside hello, and I can execute it, and it returns back the string. Tab, this is the greet function inside hello, which I can then print, just like we did before, to actually see the string itself. This is the greet function inside hello. So this is the idea of being able to return a function within another function. Let's see one last very simple example. I'm going to have a function here called cool, and what it's going to do is have another function inside of it called, let's go super cool. And this is just a string. All this function does is it returns back, I am very cool. And then this function cool is actually going to return super cool. So I can say that some func is equal to the result of executing cool. Remember that cool itself returns super cool. So now some func is actually that super cool function. And if I execute it, it'll say, I am very cool. So this is just a simple idea of having a function, defining a function inside of that function, and then returning that function. And we're going to use this as our idea of building out a decorator. The last thing we need to think about is actually having a function as an argument. With the idea of being able to return a function and assign it to something, and then passing in a function as an argument, we'll have all the tools we need to actually create our own decorator. So let's quickly see an example of passing in a function as an argument. I'm going to say hello, and the hello function now is just going to say hi Jose. So we have that function hello, and I will create another function called other, and this takes in some defined function. So notice here, this is just a variable name. I could have called this whatever I wanted. And what it's going to do is say print other code runs here, and then it's actually going to execute that function. It'll say take in that function and open close parentheses, execute it. So what does this mean? It means I'm going to be able to actually pass in a function into this other function, do some stuff, and then execute the function. This is known as passing in a function as an argument. Previously, we just saw how we could return functions and then execute them when we assign them to a new variable name. Over here, we're going to see now how we can pass in functions into another function. So this is pretty cool stuff. We'll say other, and I'm going to pass in hello. Something that's key to notice here is that I'm passing in hello. I'm just passing in the raw function hello. I'm not executing hello. So just to make it clear, there's hello when you just pass it in, and then there's hello when you execute it. I just actually want to pass in the raw function because this raw function is going to be executed inside the other function. I don't want to actually execute the function here. So I'm going to say other, pass in hello. So I don't have open and close parentheses because I don't want hi Jose. I want to actually pass in the main function there because other function is going to then execute it for me and say hi Jose. So think about what you expect to see when you run this cell. I should be seeing other code runs here. Then the other code is going to grab hello and execute it in this line and print out the result. So then I should see hi Jose. So I should see other code runs here and hi Jose when I run this. And that's exactly what we see. So now we understand that we can return functions and we can have functions as arguments. With those two main tools, we're actually going to now be able to create a decorator. We have the tools we need to quickly create some sort of device that is an on-off switch when we want to add more functionality to a decorator. So I'm going to create a couple new cells here and finally get to the part where we create a new decorator. I will say def new decorator, and this takes in, we'll call it original function. And inside of my new decorator function, I'm going to say wrap func. And what this wrap func represents is the extra functionality that you want to decorate this original function with. So what this does is we're going to print some extra code before the original function. And you can imagine this doesn't have to be a print statement. It could be a bunch of other code. Then we're going to take in that original function that was passed and execute it. And then we're going to print some extra code after the original function. So notice what we're able to now do. We're passing in the original function, adding in some extra code before it, executing the original function, and then adding some code after it. Then what we're going to do here is just return the wrap function. So you can kind of think about this as the idea of a present with some wrapping paper. The actual original function is the present, and then we're going to essentially put it inside a box and wrap around it, which is why this is called decoration. So you're kind of decorating this function with some wrapping paper, where the wrapping paper is just the extra code that can go on top of the function, before it, or after the function below it. So this is a function, just like we did before with hello and greet, except now the names reflect what's actually happening here. We created some new decorator function. It takes in an original function, and inside of this, we define this wrapper, which has some extra code before it, executes that original function, puts in some extra code after it, and then returns the wrap function. So then, I'm going to create a function here, and this function is going to need a decorator. So that we call func needs decorator. And what this does is it prints out, I want to be decorated. So the idea is we want to add in some extra functionality to this original guy. This function needs a decorator. Right now, if I just call function needs a decorator, I just get back, I want to be decorated. What would be really cool is if I could somehow add in some extra code using the framework that I built out here. And this is actually really easy. All I need to do is say, grab my new decorator and pass in this func that needs a decorator. Because remember, it's going to take the original function here. So let's say func needs a decorator and pass that in. No, I'm not executing it. I'm just saying new decorator and then func needs a decorator. So that I can call this my decorated function is equal to this function that needs a decorator passed into the new decorator. So what's going to happen is when you pass in this original func needs a decorator, it says, okay, that's the original function. And then inside of this wrap function, we add in some extra code before it. We execute that original function. So we would print, I want to be decorated. Then we would print out some extra code after the function. And with this new defined wrapping function, we return the wrapped version of this original function, which is all that this line is doing here. It's taking in that function that wants a decorator, wrapping it in some extra stuff, and then returning back a wrapped version of that function. So I run this, and then I can call my decorated function, and I see this, some extra code before the original function, I want to be decorated, and some extra code after the original function. Now what we did is actually quite complicated because I had to define all this stuff here. But there's a special syntax for what is essentially this line, and the special syntax is that @ operator. So if I wanted to actually create new decorator, what I could do is say @new decorator, say def, and then, well, let's just actually grab the original one. We're going to copy this here, paste it here, run this, and now when I call func needs a decorator, I get back some extra code before the original function, I want to be decorated, some extra code after the original function. So notice what happens here. This keyword of @new decorator, when you put it on top of a function, it just says, okay, I'm going to pass this function into this as the original function, I'm going to do something to it, add some extra code after, add some extra code, add some extra code before it, call the original function, add some extra code after, wrap that into a nice function, and then return that wrapped version. That's all the decorator is doing here. It's essentially wrapping it around. Then if you ever want to turn this off, well, it's easy. You just comment this out, and if you were to rerun this, you no longer have that wrapping. So this is now your on-off switch, having that @ symbol there. Realistically, you really won't be having to do this sort of coding of a new decorator, the wrapping function, etc. You won't have to worry about that. What you will be doing is you're going to be using a web framework or someone else's library and just adding in these new decorators to maybe render a new website or point to another page. So they're really commonly used in web frameworks such as Django or Flask, which is why it's important to understand behind the scenes what the decorator is actually doing. Now that you understand behind the scenes what it's doing, you can simply just use this abstract idea that when you tack on this new decorator, it's just decorating your function with some extra code. All right, I know that was definitely a lot to take in. You really want to check out the notebook for this one where it lays out all the steps with some explanatory text for you. If you have any questions, feel free to post the Q&A forums. I'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to be discussing generators. We've already learned how to create functions using the def keyword and the return statement. Generator functions allow us to write a function that can send back a value and then later resume to pick up where it left off. So as I mentioned, that type of function is a generator in Python. The basic idea is that generators allow us to generate a sequence of values over time instead of having to create an entire sequence and hold it in memory. The main difference in syntax when you're programming is the use of a yield keyword statement. So when a generator function is compiled, they become an object that supports some sort of iteration protocol. That means when they're actually called in your code, they don't return a value and then exit. Instead, generator functions will automatically suspend and resume their execution state around the last point of value generation. The advantage here is that instead of having to compute an entire series of values up front and hold it in memory, the generator computes one value and waits until the next value is called for. So you can imagine if you wanted to get all the numbers between 1 and 1 million. You have two options here. You can either start generating values 1, 2, 3, 4, and then feed them that way, for example, in a for loop, or you would create a giant list of numbers, 1 through 1 million, and then slowly pick off those numbers from memory. So this is what the range function is actually doing the first way. It's generating numbers. So instead of producing that giant list from 1 to 1 million in memory, since that's kind of wasteful if you're using it in a for loop, instead what it does is it just keeps track of the last number you asked for, the step size, which by default is 1, to provide a steady flow of numbers. So it's generating the numbers over time instead of creating a giant list in memory. Now, if the user did need that list, what they have to do is transform the generator to a list with list range from 0 to 10 or 0 to 1 million or whatever their start and stop values are. So that's why when we're working with range, if we actually wanted to get a list of numbers, we had to cast it to a list because range itself is a generator and it's just remembering the last number it sent out and then the step size to generate the new number. That way it doesn't have to store this huge list in memory and it makes it a lot more efficient. So let's explore now how to create our own generators. We're going to open up a Jupyter notebook. In order to get that better understanding of generators, we're going to create some. First, I'm going to create a normal function. And this function is going to be called create cubes. And what this function does is it's going to create a list of cubes from 0 up to n, whatever number the user asked for. So in this case, we'll say result is equal to a list, and then we will say for x in range n, take result and append x to the power of 3, its cube. And then at the end, we're going to return result. So if I wanted to create cubes up to 10, I run this and now I get back this list. So notice what's happening when we actually work with a normal function. We have to create an empty list and then we go for every number from 0 up to that value. We append the cubed value to this result. So we're keeping this entire list in memory. Now, that may be useful if you actually want the list, but sometimes maybe you just want to say for x in create cubes, print x. Now notice what happens when we print them. We actually really only needed one value at a time to print them. We didn't need that whole list stored in memory. In fact, we just need the previous value and then whatever the formula is to get to the next value in order to generate all these cubes. So instead of actually creating this giant list in memory, it would be better if we just yielded the actual cubed numbers. So that's what we're going to do now. So let's go back to this create cubes function. I'll zoom in here. I don't need this list anymore because I'm not going to store any of this in memory. Instead, what I'll do is say for x in range n, instead of returning the result at the very end, I'm just going to call yield, and this is a keyword, whoops, Y-I-E-L-D. I'm going to yield that cubed x value. And then if I run create cubes now, I get back the same results. It says for x and create cubes, print x, and I'm getting back the exact same thing. Except now, create cubes is way more memory efficient. The first way, if I had passed in a really big number here, it would have had to create that entire list in memory of the cube numbers from 0 to 10,000, and then from there, if we wanted to iterate through it, we would have had that list in memory. But now, I don't have this list in memory. Instead, I'm just yielding the values as they come. So then create cubes here is a generator. It's generating those values as you need them. Now keep in mind, let's turn this back to 10. If I were just to call create cubes by itself, I no longer see that list. I just see, hey, you have a generator object here at this location in memory, and you need to iterate through it if you actually want the list of numbers. If you do end up just wanting the actual list itself, you could cast it to a list and then get back the list. But create cubes itself has the option of just yielding it to be more memory efficient. So let's now create another example which calculates a Fibonacci sequence. And a Fibonacci sequence, all it is if you have a number A followed by a number B, then B is defined as the sum of the last two numbers. So let's actually show you what I mean by that. We're going to say DEF generate Fibon for generate Fibonacci. And it's going to generate a Fibonacci sequence up to n. So we can start with A equals 1 and B equals 1. Other Fibonacci sequences start with A equals 0 and B equals 1. It's really up to you. And we'll say for I in range n, I'm going to yield A. And then in order to actually recalculate A and B for the Fibonacci sequence, I can do the following. I can say, do a little tuple matching here. AB is going to equal to B, A plus B. And this allows me to avoid any issues with trying to reassign A and B while they're still being played around with. So let's walk through what's happening here. The generation of the Fibonacci sequence, it starts with A equal 1, B equal 1. For I in range n, we yield A, and then we're going to reset A to be equal to B, and then B is going to be equal to the sum of that previous A plus B. So in this case, in this first round, we have 1, 1, and then we have 1, 2. And then from there, we have 2, 3, then 3, 5, 5, 8, 13, 21. And we'll be able to see this when we run this. We'll say for number in generate Fibonacci up to 10, print the number. And we run that, we get to see this Fibonacci sequence occur. So what if this was a normal function, just to kind of show you the difference between yielding something and creating a normal function? In that case, we would have to store everything. So we would have to say output as some empty list, and instead of yielding everything, we'd have to say output append A, and then after we did that entire for loop, I would end up returning the output. And if I run this, it looks the same as the results, but this is way less memory efficient because I'm holding everything in a list in memory instead of just yielding them as I need them. So when you want to iterate through some sort of generation sequence, it becomes a lot better to use this yield keyword instead of storing thing in a list, especially if you expect that number to be really large and if you're creating a huge list. So the key to fully understanding generators is the next function and the iter function. So let's explore those concepts now. I'm going to create a couple new empty cells here. We'll first start off with the next function. So to do that, I'm going to create a very simple generator. And all this generator does is it says for x in range 3. So I've already predefined the range. We won't have the user pass that in. I will yield x. So what does that actually mean? It means if I say for x in simple gen, print, actually let's say number so we don't get confused by the x in there. We say for number in simple gen, print number, I get back 0, 1, 2. So let's now assign g equal to a new instance of simple gen. So notice here I'm actually calling simple gen here. And let's take a look at g. It's this generator object, and I can ask for the next g, and let's print out the result here. And I get back 0. So then if I ask for the next one, after that, I get back 1. And this is what the generator object is doing internally when you call that yield keyword. It's remembering what the previous one was and then returning the next value given whatever formula it's following. It's not holding everything in memory. So then we can print out the next g, and we get back 2, and then eventually you're going to see, because we only went up to 3, it'll say stop iteration, because after yielding all the values, next calls a stop iteration error. And what this error does is it informs us that all the values have been yielded. Now you may be wondering why we don't get this error while using a for loop. And that's because a for loop automatically catches this error and stops calling next. So this is another interesting thing to think about. When you're actually calling this for loop on this generator, what the for loop is doing is it's saying, hey, give me the next thing. Hey, give me the next thing. Hey, give me the next thing. So that's what this for is doing internally on this generator object. Finally, I want to show you the iter function. So iter. And the iter function basically allows us to automatically iterate through a normal object that you may not expect. So I'm actually going to first say s is equal to hello. And I already know I can iterate through the string. So I can say for letter in s, print the letter, and I get back hello. Now unfortunately, that doesn't mean the string itself is going to be able to iterate with the next function. In fact, if I say next on s, it'll say, hey, this string object isn't an iterator. So what this actually means is that the string object does support iteration because we went through a for loop on it, but we cannot directly iterate over it just like we did with a generator using the next function. In order to do that, to basically turn this string into a generator that we can iterate over, we're going to say s underscore iter, and then we call the iter function on it. And then now we can call next on the iter version of it to get back h, and then we call back next on the next one, we get back e, and so on. So now you know how to convert objects that are iterable into iterators themselves. And I know there's a lot of kind of strange semantics here, the iterators, iterable, and generators, but the main takeaway from this lecture really has to do with that yield keyword. So if you scroll all the way back up, if you really are going to take one thing from this lecture, it's really how to create your own generators with yield. Usually when you're working with code, you're not going to be actually using that next function that often, and you're not going to be using that iter function that often. Really, those are being called behind the scenes for you already. What you will be using is this yield keyword when you eventually find yourself creating your own generators. You can check out the notebook, which has 2 links at the bottom for really useful Stack Overflow answers, explaining some more aspects of generators. Coming up next, we're going to just quickly check your knowledge to make sure that what we discussed about the yield keyword stuck with you. So we'll see you at the next lecture where we go over some generator questions. We'll see you there.